All right, let's talk about how to do some unit conversions. In this video, I'm going to show you how you can convert any unit. And so it doesn't matter if we're doing feet in inches or radians, degrees, this will work no matter what the unit is. So I think a lot of the time, if we see some basic ones, for instance, if we have 2 feet and we're asked to convert over to inches, we know that's 24 inches. And we don't really show a ton of math just because we kind of know it off the top of our head. And I know a lot of different teachers will show you different box methods or different ratios, things that you can set up, or just every single time you see a foot, you multiply it by 12. I'm not going to teach any of those because I want a method that works no matter what. If we understand what's going on, I can convert anything in the world. So the idea behind a unit conversion is that we're going to be multiplying by 1. And the idea behind that is I know I can take any number and multiply it by 1 and it stays the same. So for instance, 2 times 1 is equal to 2. That's obvious. We've used this fact, we use it all over the place and we don't even think about this. This is called the identity property or the multiplicative identity of real numbers. And so that anytime I multiply 1 by any real number, it stays the same. And so we use this in fractions. Say if I had the fraction 1/3 and I want to have a common denominator with say 6, well, I'd multiply by 2 over 2. Once again, I'm multiplying by a unit. I'm multiplying by 1. This right here is 1. So we multiply by 1 in a clever way to get to a desired result. So as long as we're multiplying by 1, we never change the number. And we're going to rely on that fact. So let's go back to that 2 feet that we started with. If I want to convert this over to inches, my goal is to have just inches at the end, and I want to know what number I need to have attached to that inches. I know I'm multiplying by something, right? And I have to multiply by 1 to get it to be the same. Well, if I want inches, I'm going to have to multiply by inches on the top, right? That's my goal, is to have inches, and this inches clearly in the numerator because it's not in a fraction. And I want the feet to cancel, and I know anytime that we have the same thing top and bottom, they would cancel. So if I put the feet down here on the bottom, they would cancel. So feet on top, feet on bottom, we would be left with just inches. But I need to get this ratio right so that I'm really multiplying by 1. And I know that 12 inches is 1 foot. And now, in this green box, this ratio right here, 12 inches, 1 foot, these are the same. So this ratio here is just 1. So by multiplying 2 feet by 12 inches over 1 foot, I guarantee I haven't changed the number. The same way as 2 times 1 is 2, that didn't change the number. When I multiply these two things together, I'm left with 24 inches, and that has to be the same as 2 feet because I multiplied by 1. We can do this, like I said, with any number of things. So if I take, say, 5 hours, I know that there are 60 minutes in 1 hour. So again, in the green box, this has to be equal to 1. So I am not changing the number. But because hours are on top and bottom, they would cancel, leaving me the unit of minutes. And then if we have 5 times 60, that would leave us 300. So 300 minutes has to be the same as 5 hours. We can make things bigger. We can also make them smaller. So for instance, if we had, let's say, 240 minutes, and we wanted to convert that to hours, I'm going to multiply by 1. I need this time, because minutes, we start with minutes, I have to put the minutes on the bottom. I'll put the hours on top. That way the minutes will cancel and the hour will be left. I know that 1 hour is equal to 60 minutes. This time when I multiply, I have the 240 times 1 over, remember, anytime we have a whole number like this, that has to be over 1. So I have 240 times 1 over 1 times 60, which would give us 240 over 60. And I can simplify that. 240 over 60 is equal to 4. So that has to be 4 hours. The hours being in the top here, it got a little messy. But the hours are what's left. We can do this any number of times. So if I start with 2 hours, we'll use hours again. And this time I want to go to seconds. My goal is to have seconds over here on the right-hand side. I'm going to start by multiplying by the ratio I know is equal to 1, and that will get me to the next smallest unit that I know. I know 1 hour is 60 minutes. So I don't necessarily know hours to seconds. I don't know that direct relationship. But I do know that 2 hours, I know that 1 hour is 60 minutes. But if I were to cancel out those hours, I'm still left with minutes, and minutes is not my goal. Minutes is not seconds. So I'm going to add another unit in here. I know that 60 seconds is equal to 1 minute. And so I've created a chain here. And all of the things that I didn't want, the hours and the minutes are canceling, I'm left with seconds. So I've taken kind of 2 steps to get to my end result that I wanted. 60 times 60 would be equal to 3,600, and then times 2 would be 7,200 seconds. And so this works no matter how many things we have in the sequence. We can reduce, or we can to make bigger. So we reduced in this line, we made bigger again in this last example. So if we take something like degrees and radians, we know that pi radians is equal to 180 degrees. So if I put that as a ratio, pi over 180, that has to be equal to 1, pi being the rads, the radians, and that has to be equal to 180 over pi radians. All of those things are equal to 1. So if I say start with, take 30 degrees, well, I started with degrees. I want to get to radians. My goal is to have the rads. And I know that if I start with degrees, I'm going to have the degrees on the bottom of my unit ratio. I know that 1 radian is equal to 180 degrees. If I multiply 30 times 1 is 30. On the bottom I have 1 times 180, that's 180. 30 over 180 would give me, sorry, that should have been a pi radians, not just 1 radian, pi radians. That should give me pi over 6. 30 times pi, and then 180 times 1 on the bottom. 30 goes into 180 6 times. If I were to go the other direction, let's say we start with a radian measurement, something like 7 pi over 9. I know that's radians because it doesn't have a degree symbol on it. I have to multiply by something, and because I had that understood radians here, put it in green, just because it's not written doesn't mean it's not a radian measurement. If I have radians on top, that means I need the radians on the bottom. I know that pi radians corresponds to 180 degrees. That means the radians will cancel. I know that 9 goes into 180 20 times. So I have 20 times 7, or 140, and then the pi's would cancel as well. So I'd have 140 degrees.